We will start with the Internet Security Threats session now. We'll start with Mr. Khaled Fadda from Arbor. We'll talk about introduction to DDoS attacks right now. Please, Khaled.
Thank you. Good morning, everyone. Thanks a lot for coming again. And I would like to thank MENOG to give me the second opportunity to present again about DDoS. Before I start, I need to ask a question. Is there anyone who did not attend yesterday's session about the DDoS? 2, 3. Okay, for the guys who attended yesterday's session, you will see almost the same slides, but what I did, I shrinked the presentation to have just only a few slides to focus on the type of the DDoS attacks. I'm including today a live DDoS attack taken from a live running system, so we can see some amplification, reflection attacks in the real world. So it's going to take about just only 25 minutes. This is what I have. So if you have any question, please feel free to ask. Okay, so as an introduction, what is the DDoS attack? DDoS attack came from distributed denial of service. So the objective of the attacker using the DDoS attack is to consume the resources that you have in the network, which means the attacker is focusing on the availability of your resources. So if your resource is unavailable, that means no service. That means there's an impact on the services. That means you are losing money, you are losing business. When we say a resource in the network, could be anything. It could be service that you are providing, it could be a router in the network, it could be a firewall, it could be a link, it could be anything that you have in the network. The problem with the DDoS, it is distributed, which means it has to come from distributed sources. So usually the attack comes from multiple of sources, different IP addresses, going to a single destination, to a single target. So why we are focusing on the availability and why maintaining availability is really hard. Unfortunately, most of the organizations today, they do not focus on the availability, or even they do not link the availability to the business continuity. So when you go to any organization and you find they are working on redesigning the network or enhancing the security, 90% they are not including the DDoS into their consideration. In practice, we see a lot of customers, they're building huge data centers, but they do not do a stress test even for their devices, servers. So once they have an attack, they will say, okay, this is what we can carry. It's not a DDoS attack. We did not do a stress test, so we will be confused if it is a DDoS attack or real traffic. The DDoS attack can be anything, can be a combination of multiple types of traffic. DDoS attack can be a huge volume of traffic. It could be a specific traffic going to a certain application, or a specific traffic going to certain service. And the objective again about the DDoS is to disrupt the service, to make your service down, focusing on the availability. The most famous attacks for the DDoS is the amplification reflection attacks. I'm gonna focus a little bit about this type of attack. I'm gonna show you a live attack as well about amplification reflection attack. Another problem with the DDoS, the traffic could be spoofed. So the attackers, they're trying to spoof the victim. They're trying to use a third party, or let's say another source available in the internet, and they're trying to generate that attack. And we see new trend for the DDoS that most of the DDoS attacks that we see like a pulsed attack, like spikes. So the attacker is gonna generate, let's say, traffic, 400 gig as an example, for just only, let's say, 30 seconds, and it's gonna be off. Then the attack is gonna come back again. This is pulsed attack. To talk about the DDoS attack, so we can categorize the DDoS attacks into 3 major types. DDoS attack today is not just only a single type of attack, not like before. If we are in 2000 or 2002, 2004, so we can say, okay, the DDoS attack is just only a volumetric, it's just only a flooding attack. But now the case is not like this. Today we can divide the DDoS attacks into 3 major type of attacks. The first one is the volumetric or the flooding attack. This is the most famous attack. So the attacker is gonna send a lot of traffic, like if you have 1 gig, so we can send 5 gig of traffic, so the link is down. This is a flooding attack. The second type of attack is focusing on your security layer. You have firewalls, load balancers, IPS, whatever security device that you have in the network, so can be attacked by a DDoS, even if that device has some DDoS feature built in on it. The third type of DDoS attack is an attack targeting applications. So if the application is a website, if it is a DNS, if it is a VoIP, so the DDoS can attack that application. The DDoS can make that application or service down. The problem with the DDoS attack can attack anything in the network. It could be on a router, could be on a link, could be on the interface, on a server, on anything in the network. So how DDoS attack works? So if we look at this slide, we will see here the internet, and we will see a service provider, and we will see a customer connected to the service provider. This part, it could be a database, or I would say a data center, including a database inside it. So as a DDoS attack, so the attack has to come from multiple sources, not just only from a single source. So let's imagine this guy is sitting here. He would like to attack one of the servers inside the data center. So this guy, he's gonna select the type of the attack, like application layer attack. He's gonna prepare the tools. He's gonna prepare something called command and control. Command and control server is the server responsible to give an order for the infected PCs. Infected PCs, we call them zombies or bot. This guy needs to get control on some infected PCs or on some bot. So if you put the bots, the infected PCs, with the command and control, then we have something called botnet. So botnet means it's a network exists controlled by one or more command and control servers to send malicious traffic. So once the attacker has this enough number of bots, we might have 100,000 of bots in the botnet. So he's gonna give the order for all bots to send a traffic to attack the target. So as an example, this command and control is gonna say, okay, today at, let's say, 1 p.m., I'm gonna start this attack. So the DDoS attack is gonna come from multiple of sources going to a single destination. The problem with this type of traffic, it looks like legitimate for most of the network components in the network. Routers will see, okay, it's a normal traffic coming from multiple sources. Firewalls will say, okay, it's just only a normal traffic. IPS is the same. But in reality, it is illegitimate traffic. It is an attack. And the objective of this attack is to make the resources down. Why we need to use botnets? Well, botnets, it's an easy way to generate a DDoS attack. They're usually cheap. If you need to get a botnet to generate an attack, it's very cheap, like $50 per day. And the botnets usually untraceable because you are generating the traffic from multiple of source IP addresses. And even you do not own that IP addresses. The bots could be inside the country, outside of the country. You're just only using them to send the traffic. And the problem with bot that nobody is trying to clean the bot. The bot is usually a machine infected with a malware running on the background. We are not doing anything. We are not stealing any traffic. Just only the attacker is trying to use that malware to send traffic from that PC. Talking about tools for the DDoS, we do have a lot of tools available on the internet. The most famous one is this one, which is called LOIC, Low Orbit Ion Cannon. This tool has been downloaded more than 1 million times in just only 1 year, which is an indication that most of the attackers now, they are focusing on generating DDoS attack. And today, the DDoS attack, we see it, it is used to be like a smoke screen for other type of attacks. We do have a lot of tools available on the internet. You can just go, Google it. You will find millions of tools free. You can download them, and you can do attacks. Another thing, you can volunteer to some groups. Anonymous group, they do campaigns. You can participate in the DDoS attack, and we see it in the region. Another thing, if you do not want to create the DDoS attack by yourself, you can buy it as a service. And if you go to the internet, you will find a lot of such guys offering the DDoS as a service, the DDoS attack as a service. This is just only an example for one guy. He's saying he has a special edition for a tool called Bot.Jumper version 5. He's saying that he can create these type of attacks. TCP send flood, HTTP get flood, HTTP post flood, and so on. And the problem with this, the prices are really cheap. So if you have a look here, okay, if you need to do an attack for 1 hour, it's just only $4, which is nothing. And at the end of the day, you are not doing that attack. He's doing that attack on behalf of you. The problem with this attacker, he's saying prices may change if target have anti-DDoS protection. That means this attacker is doing something called multi-vector attack, which means he's going to start with a single type of attack or 2 types of attacks. If the target has a DDoS solution and trying to block the attack, so he's going to change the vector to bypass that solution. It's really dangerous. So talking briefly about type of attacks. So the first type is the volumetric. So if we look on this diagram, we will see that, okay, we have an ISP connected to multiple of ISPs. We have here a data center. We have a security layer. We have the application layer. So the first type of attack is going to come on the uplink. This type, we call it volumetric attack or flooding attack. Usually, the attacker sends a lot of traffic, a large volume of traffic. So if you have 10 gig link, so you can have 100 gig of traffic, the link is saturated, so nobody can get access to the service. This is called flooding attack or volumetric attack. The impact on the network, of course, most of the links, uplinks, core links, some of your network elements will be down because there's no service. Common names for this like the packet flood, UDP flood, TCP flood attack. Talking a little bit about the protocols used for the flooding attack, UDP is one of the most famous protocols used to generate such type of attack. UDP is a stateless protocol. There's no complication like the TCP. There's no three-way handshake. It's easy to be used. In the UDP, you can easily spoof IP addresses. You can easily change the size of the packet. So one of the examples for the UDP, if you send 1 million packet per second, and the size of that packet is 60 bytes, that means we can generate 458 megabits per second. If you send the same amount of packets, but you change the size of the packet to be 1,400 bytes, so we can generate 10 gigabits per second. It's a large volume of traffic. The second protocol is the TCP. And if you look at the TCP, it's a three-way handshake protocol. And the attacker is going to misuse that way. So if you look at the TCP, how it works, you will see that, okay, we have a send request coming from the initiator going to the listener. The listener is the server or the other side that needs to respond. He's gonna get back with a send acknowledge. Then the initiator is gonna send acknowledge. That means the TCP session is established. After that, we can send the traffic. So the attacker is gonna misuse this one. He can send something like TCP send, just only sending this part. Send. That means he's gonna keep the other party waiting. Okay, I'm replying with the send acknowledge, but there's no acknowledge is coming. So I'm consuming the resources of the server. Another technique, we can send, let's say, like a FEN, TCP FEN. That means, okay, there's no TCP session already established, but as a listener, I'm sending, or as an initiator, I'm sending a FEN request. So we can misuse this protocol. And usually the DDoS attacker looks at the protocol, how it works, look at the application, how it works, then he's gonna change the way. One of the famous examples for the bandwidth or the high bandwidth attack is the reflection amplification attack. In the amplification reflection attack, the attacker is gonna use another part or another resource on the internet to attack another destination. So it includes a spoofing of IP addresses. So usually the attacker is gonna spoof the victim IP address, is gonna send the traffic to another resource, like a abusable server, and the server is gonna reply back to the victim with a DDoS attack. Some examples for this, like a DNS reflection, DNS-SIG amplification. So this is an example about using the NTP to do an amplification reflection attack. So the attacker is here. The victim is here. We have abusable servers. So look at the request coming from the attacker. The attacker is gonna send an NTP query using a UDP port source 80, and the UDP port destination is 123, which is the NTP. The size of the packet is 50 bytes per packet. And he's spoofing the source. So the source is gonna be spoofed, which is the victim IP address. This IP address is here. The destination is multiple of NTP servers exist on the internet. Could be CPEs that has NTP enabled, could be NTP servers accessible, not very well secured. And he's doing this NTP query using the monlist command. It's a command you can generate it on the Linux. So if you have a Linux, you can generate this command easily, and you can do this type of attack. Now, this part, the red one itself, sending the traffic from the NTP going back to the victim is reflection, because I'm reflecting the traffic from the NTP going to the victim. Now, if you look at the details, you will see that, okay, the source is UDP 123, the destination is port 80. Look at the size of the packet. It's 468 bytes. This is amplification part of this type of attack. So the response is really huge. And the source is the multiple NTP servers, is non-spoofed. It's valid IP address, is not spoofed IP address. And the destination is the victim. Other protocols can be used for amplification reflection attacks. So the NTP is here. We can use DNS, charging, SNMP, SSDP protocols. If you look at the NTP, we can have 1,000 amplification factor. So you can send one packet, say 50 byte. So the reply is going to be 1,000 multiplied by 50. If you look at the abusable servers that can be used on the internet, we have over 100,000 servers available for such type of attack. If you have a look on the DNS, we have millions of servers available on the internet that can be used for this type of attack. The latest study from 2015 shows that the DNS is the mostly used protocol for amplification reflection attack with 84%, followed by the NTP, then SSDP, then other protocols. The second type of attack is the exhaustion of a state. It is an attack usually targeting the security devices, the firewalls, IPSs. So the attackers know very well how those devices work. Most of the security devices, they have a stateful table, so we have to maintain session as a firewall. So, and that firewall or the IPS has a limitation in number of sessions that can be maintained. So simply, the attacker is going to send a lot of TCP, let's say, requests. He's going to fill that table. So the firewall is going to be down. Symptoms of the firewall, which is under DDoS attack, CPU utilization is high, memory utilization is high, you are not getting access to the firewall. This is a DDoS attack coming to the security devices. The third type of attack is an attack going to the applications. And here we do have a lot of applications available for the organizations. HTTP, DNS, VoIP, anything. Usually the application layer attack is not that huge or big in the volume of traffic. Usually it's an attack huge in number of packets. So the impact on the network is limited. So if you have, let's say, 1 gig links available in the network, so the application layer attack, it could be just only in megs, like 100 meg, 200 meg traffic, but we are targeting an application. Common names for application layer attack, like the URL floods, Rudy attack, RUDYETS, LOLORIS, LOIC, HOIC, the tools that we've seen, DNS dictionary attack, we have a lot of attacks. I do have here some examples for web servers attack, like the git flood, slow git, slow post. The idea behind these attacks is to consume the resources of the server. So in the slow git as an example, so the attacker is going to send a lot of requests, GET requests, but that requests are not complete, incomplete requests, making the server waiting for the rest of the query or for the GET request. In the slow post is like the GET attack, but the GET request is complete. But in this case, the attacker is going to send the information that is requested by the servers in a very slow bit rate, keeping the server just only waiting for the information. We do have a lot of attacks going to the DNS as an application. DNS amplification, we've seen it. We have non-existing domains, so the attacker can send a lot of requests, a lot of DNS queries to the DNS with non-existing domain. So the DNS is going to be busy just looking for the IP address of that domain, requested domain. Again, to the statistics, DNS is the top application targeted by the attackers with a 78%. In 2014, the HTTP was #1. 2015, we've seen that the DNS took over the HTTP. Now, if you combine the three types of attacks together, we will have something called multi-vector attack. And this is the problem today. So today, the attacker is going to start with one single type of attack, then is going to change that attack if the target has a mitigation solution. And because we have a lot of botnets available, a lot of tools available, motivations are more and more, so we have very complex attacks. So we see every year increasing the complexity in the frequency and in the volume of the DDoS attack. Some statistics, and this diagram shows the size of the attack in 2004 up to 2015. As you can see, 2004, the largest attack was almost 8 gig, but in 2015, we are talking about 500 gig attack. This is really huge. Talking about complexity, most of the customers, they said, okay, they received a multi-vector attack. Their percentage was 56% of the customers, they got a multi-vector attack. 17% just only said, we received a DDoS attack, but it was a single type of attack, like a volumetric or application. In 2015, if you look at the percentage of the attacks, 65% of the attacks were volumetric, 18% were exhaustion state, another 18% were application layer attack, DDoS attack. Talking about the solutions, Firewall IPS is not the right thing. If you believe that you are protected from the DDoS attack using IPSs or firewalls, unfortunately you are not correct. because we have the second type of attack, which is exhaustion of state. So the attacker can make that security devices down, and then he can get inside your network. So you need a solution for the DDoS. In brief, we have some techniques about how to react for the DDoS attack. We have access control list as one of the mechanisms. We can use the black hole filtering, the RTB-H, as another technique. We see some customers, they're starting to use the BGP Flood Attack to block the attackers. We do have in the market the on-premise IDM solutions, the solutions that is focusing on the DDoS, doing surgical mitigation. And at the end, we have the layered DDoS attack surgical mitigation approach. For the first three techniques, the access control list, black holing, BGP Flood Attack, it's into more black holing. So in the three techniques, what we usually do, we block the source, the whole source, or the whole destination. So if we have an attack going to a destination in the network, like one of your servers, so all that traffic goes to that destination is going to be black hole. It's going to be sent to null zero as an example in the router. Well, we protected the service from the DDoS attack, but if you look at it from another hand, you are preventing anyone to get access to the service. So, and somehow you are helping the attacker. Well, you are protecting your resource from the DDoS attack, but you are preventing any access to that server, which is the objective of the DDoS attacker. The same thing happens with the access control list and the source-based remote trigger black hole. Beside that, it's very manual process. You have to write the commands, you have to analyze the traffic, it's gonna take some time. In the on-premise IDM solution, it's a surgical solution, can detect attacks, can do the mitigation automatically. In the layered solution, like this one, as we've seen, the DDoS attack can impact uplinks, can impact core links, can impact data center services. So we need to have a layered solution. Because if you have the attack coming on your uplinks, whatever you have in the network, you will not be able to do the mitigation, so you have to contact the upstream provider, and so on. So this is the layered DDoS attack. So this is for the slides. I just need to show you a live attack. Okay, cool. So first of all, I need to show you this website. This website called Digital Attack Map. It's a website developed by Google. They said, okay, we need to increase the awareness about the DDoS. So they decided to build such a website that shows live DDoS attacks happens in the world. And to build this one, actually they came to Arbor and they said, okay, because you have this visibility, you have this experience in the DDoS, so we need you guys to feed us with the information. By the way, you can access this website. It's free of charge. Just go to the Google, search on Digital Attack Map, and you can find it. But if you look at this one, you will see attacks between two countries. If you click on one of them, just put the mouse on it, you'll see some details like, okay, we have here an attack is running between US and UK. The size of the attack, almost 100 gig, okay? Duration, 18 minutes. The source port used is 80. Destination port, we have variable ports. And the class is TCP connection. It's a protocol attack. If you, let me go back by time. Of course, you can go back by time. Let's say we have here a lot of attacks. Let's have a look here. So we have an attack like a circle. That means it's an internal attack inside the country. It's an attack generated internally in the country. If you look at the attack again, you will see some details like this is a volumetric attack using HTTPS 443 port. What you can do as well, you can select attacks by type, source port, duration, destination port. You can go down, you can explore the largest attacks happen, let's say, over 2 or 3 years. So you can say, okay, if we need to explore the gallery, let's find one of the attacks. I can see here a storm that was happened in December 26th of 2013 in US. So let's have a look on this type of attack. Wow, it's like a storm.